Welcome everyone to Yahara Software's August installment of our Biohealth webinar series, From Mandate to Method, Developing Practical AI Strategies in Biohealth Organizations. If you've joined us before, you'll recognize our hosts, Adam Steinert, our CTO, and James Magala, Bioinformatics Practice Manager, who lead this ongoing series. Today, they're joined by special guest George Mayhew, Manager of Research Informatics at Arrowhead Pharmaceuticals. Together, they'll explore how biohealth organizations can translate executive AI mandates into actionable strategies, build fair, aligned data infrastructure, and apply AI in real-world drug discovery.
Thank you, Ashley. And George, thank you. Welcome. It's good to have you with us today. We in the past, year and a half of working with companies, there has been a lot more emphasis on AI and machine learning and how those technologies can be implemented as technologies advance, so quickly. The capabilities, possibilities have really grown exponentially. And one of the things that everyone, is working through, I think, at this point of the technology curve is when and how to implement, those projects in strategic manners that really helps to push operations and science forward. And a lot of that starts with the mandates that, come through in organizations as people start to filter their information. How can we use these tools to help us to provide a competitive advantage to our operations? George, this is something near and dear to your heart, and so we'll kick this off with a question, to you in your capacity, in your experiences. What are some of the specifics that you run into as you and the company that you work for have tried to start assimilating those? How are you leveraging these tools today, and what are some of the challenges you're running into?
I think as far as some of the tools, addressing that specifically, is largely a question of data summary, right? How do you take information that you have either in disparate locations, data siloed, or even in a structured data environment, and be able to collate that and summarize that in a meaningful way that is useful to your researchers, right? As far as the challenges go, I think probably the biggest challenges are things like legacy data that are often in very unstructured, disparate data sets, collections of Excel documents, Word documents, PDFs, OneNote, Google Notes, just everywhere, right? And I think that's probably a problem that's in what you might consider sort of transitional biopharma, where you have relatively small companies that are moving themselves up the developmental ladder and growing rapidly. So you've still paid for these assays and the data, so you still want to be able to leverage that after, potentially months or years after it's been generated.
I almost see that as a problem of what do we have, right? What can we leverage to help us out? When you bring up the idea of siloed data, if executive groups coming and saying, look, we want to leverage this, is there, what's the discovery process there? Is there kind of a discussion amongst peers of, okay, well, how do we bring this all together to do something that's really game changing? Obviously there's an end goal, right? For every company, there's a reason for being and a progression, through that execution. But sorting through the what is capable and what isn't, and how do you marry that to sort of strategic goals?
So I think that end goal, I mean, companies themselves obviously have end goals. They have targets, they have objectives. Mandates for utilization of AI or utilization of data, I think, are always a little sparse at the beginning. And they're not always treated like projects with the same kind of specific goals that the corporation, the company has for their outputs, whether those outputs be sales targets or whether they be clinical, getting into clinical phase, clinical trials. So the call out for AI becomes, I think at the beginning anyway, how do we, right? how do we leverage AI? How do we leverage the tools? How do we leverage the data that we have? And sometimes the answer to that latter question, how do we leverage the data that we have, is, well, we're going to need to use AI. Kind of things. I think we end up with scientists and data managers who end up having to convert these requests into actual actionable projects. So it has to come down into your decision making groups in the discovery areas, and then has to go back up the corporate ladder as far as like a project goal.
In some respects, James, this reminds me of one of your common catchphrases of the year: "Data science is science." There's an exploration that happens.
There's a huge amount of exploration that happens, and I think what George is describing here is very true across sort of any scientific organization. But it's also true, like to your earlier comment, George, about the Excel part of this. The modern enterprise runs on Excel. That is the tool has been available that a lot of people use, and you now get told use AI. I don't really have a corporate strategy for that. I don't have a way to get it into my environment. I don't really understand how to make it work with my data. I'm not set up to do this. This is terrifying as a frontline scientist. And so what you do is fall back on your old habit. I'll just start another little Excel notebook over here and start putting some data into it, because that's what's available. There is a mentality shift that's going on right now, and that's sort of where Adam is going with this. I've started turning that phrase on its head too. Data science is science. In the current complexity of data, the larger volumes, the many factors that are likely to be in there influencing your results, you need some data science approaches to do modern science. And it's starting to turn upside down to the point where I've started telling people science is becoming data science. You are going to need some of these more advanced tools, but that's not the same thing as that AI mandate that got handed down from on high that said, use AI, go faster. How do we start to build a system that is approachable for the scientists, that starts to work a little more ground up, that's subject to a little bit more of that sort of managed approach, that turns it into a real enterprise initiative?
Yeah, that's a great question. So ultimately, there has to be money behind this, right? So you need to budget this, and you need to plan, right? So, and you have to take a long view. You can't say, well, we need to use AI today because companies like In Silico Medicine can crank out a drug in 18 months. They have, at the very beginning, they built an infrastructure to support using AI. They basically developed that company from the ground up as an AI-based company. More traditional biopharma have to learn. And a lot of that is a kind of a dreaded term, databases, right? So installing databases, LIMS systems, but also more results-focused type databases, more open-ended things that are quick to change. LIMS systems are usually fairly rigid, but
Yes.
other platforms that allow for quick adoption of new methodologies. But the end result is structured data that comes out and is built in your entire AI strategy gets built on this concept of AI ready data, right? So these take time to build. So the company needs to put as part of their mandate infrastructure, both personnel, tools, hardware if necessary, software, et cetera, to build out these infrastructures that can then support these AI-ready data. Like I said, they have to take a little bit of a longer game to it. So because your development cycles on these are anywhere from 3 to 5 years. So, but ultimately, I think, hopefully, once you get to that point, you have adopted strategies and methodologies and have brought that culture into your organization as well. So a more data-centric, data-focused culture that then when somebody is designing an experiment, part of the design includes where the data is going to go. Right. It's not going to go into, on my local hard drive in an Excel document and a text note. It's going to go into your structured databases. So,
And there needs to be a right place for it to go, a clear process that gets it there, a right place for it to end up. And that's what starts to enable that. That's how you get to some of those more clear requirements that turn this into a proper project, a proper initiative, instead of a unfunded mandate.
Yeah, and you said one of my favorite words, requirements. At the very beginning of these processes, you have to establish discrete goals and discrete outputs, and you need to describe in detail what those goals are and what those system requirements are going to be. And you have to engage your user base with that as well. So because ultimately the people putting data into the system are your users. So I've seen way too many database systems that are well designed for the analytics at the tail end, but are absolutely atrocious for data entry.
Yeah.
So how do you balance then, George, that need for both, the requirements up front and the goals with the flexibility to adapt to the changes that may happen along the way, particularly in something with a time span of that duration?
Yeah, that's tough. I think there has to be sufficient enough support and sufficient. So first off, there needs to be executive support for the initiative, period, hands down. Without executive support for it, you can't build these types of systems from ground up. They can't originate. Well, I suppose it can originate, but
It
even if you
won't
have
grow up to
scientists
be.
who are basically saying, I need to have this kind of thing, unless you've got some sort of executive support for it, you'll never get the money or the infrastructure or the budget that you need for it. So in a large part, the decisions have to start or disseminate from the executive level. But then I think what's really important is you have to approach it from with good project management practices. You have to have good design. You have to be very user focused. You also have to be very output focused. So, in like you said, Adam, it's kind of a balance. So there has to be a vision of how these data systems are going to support your science in the first place. And I have found that those end up being driven mostly by teams in such a way that teams, and again, they can be pretty high level teams, and be your primary discovery PIs, who basically say, for us to be able to process the amount of data that we're going to need to generate, we need to have a system that helps us to find all of that data.
To the point of specific tools, George, are there implementations that you feel okay, these tools really help facilitate that, or is it really more about the planning and the process and the adaptability of the team?
So it helps to have external partners for things like this. And if you're going to go the direction of, say, software as a service, there are definitely some industry leaders that can help with that. At Arrowhead, we're using Benchling as a core platform to get our data into a structured format, mostly because of its flexible approaches to data entry and its quick adoption of sort of workflow-based and assay-based data collection. They're not the only ones in the field. There's certainly plenty of others, but it's kind of more of a partnership relationship because the expertise to build these things out exist outside of our company, right? There are certainly much larger organizations. I think of like Roche and Sanofi, who have large core software development teams, and they're capable of deploying their own LIMS/data tracking system that matches precisely the science that they do. But again, at some level, there has to be a lot of project oversight from a PMO is very helpful. And again, recorded requirements, go through some basic software engineering practices, CI/CD, et cetera, to get a system that supports the science you're doing today as well as the science you're likely to do next week or next year.
Well, I mean, and it's good to know that there are partners, there are systems out there that smaller companies can engage with to I think in general that's one of the fascinating things about the technology space right now is some of these things that even 6 to 12 months ago we might have thought were intractable problems have become much more available, particularly in the AI machine learning space, with the tools that have progressed so quickly.
And there's a theme there I want to unpack a little bit, Adam. This is stuff that we've been talking some internally. In a lot of ways, getting some of that legacy data, the more siloed stuff, the unstructured data, and underpinning it with enough structure to start to apply the next set of tools, look at the next set of strategic goals in the context of that data. We've started using the tooling itself to bootstrap the quality of the data back up to modern standards. Spend just a minute there talking about using AI to get to a place where you can use AI, because I think that's become sort of an interesting theme here.
So you're sort of leading into like maybe using agentic systems that can automate some of the conversion of data, or
That's one of the things that we're seeing, but also in machine learning space, if you don't have enough data, using it to iterate and synthesize more so that you can bootstrap up to a high enough quality, or organizing your existing data, taking it from unstructured to semi-structured, or semi-structured into a fully structured database ready for downstream analytics. What are the opportunities that are there?
yeah, there's an awful lot of tooling that has to be done with with some of that, right? And I think some of it is just having knowledgeable software developers that can go out, find, and scrape data from disparate locations. Some of those developers are actually leveraging generative AI tools and LLMs in particular to at least find the data and create outputs that could then potentially be brought into one of your other fair data systems, right?
Yeah.
So
That's sticky, right? That's real sticky.
Well, but it's the start of that fair data conversation, and that's sort of where I'm going with it.
Gotcha.
In the past, I would have told you the problem with fair data is that most data isn't fair, and it is a huge chunk of subject matter expert hours and expertise to pull all of that back into a more compliant stance, a more fair stance. Fair is so hard. We're spending so much time doing it. Are we getting value back out of it? My view on the
James.
world is starting to pivot a little bit. Yeah, go.
Well, no, I think I'd love to go explore that, but I think maybe we should take a minute. Maybe, George or James, you could talk about, what fair data is for audience members that may not be aware, and why it's important in this space in the context of what we've been talking about here.
George, you
Right.
get that one.
So FAIR, FAIR, right, is an acronym. Findable. I've just forgotten what the A was. Do you remember, James?
Accessible.
Accessible. There we go. Interoperable, right?
Mhm.
And this the R always gets, I think, a little bit flopped around as to what that actually means. I've always seen it and interpreted it as reusable.
I would agree.
So the idea there is that any data that you've generated, whether it be legacy data, you've spent the money to generate it. You should be able to use it in other experiments, not necessarily just what it was designed specifically to answer, but can be used as, say, metadata across, or data across a meta-analysis or something along that lines. So yeah, so getting back to sort of how the acronyms work, findable, right? And I think there's a lot of focus in the tools that are available right now on that piece, right? And who is supposed to be leveraging the findable part. Right? Is it your computational specialists? Is it your bench scientists? Is it your lab, your lab assistants? Whatever. Accessible is all about data governance. Who has the ability to actually see the data that you've created? Interoperable for me has always been the can it be ingested into various different kinds of systems than for downstream analysis, right?
No, I think that's a great definition of it, and it's a laudable goal, and it's a big theme that we hear a lot, particularly in kind of the biopharma space. There's a lot of emphasis here. We know that this is a thing people are worrying about. Part of the reason that I'm poking at it from the tooling perspective is it's one of the hangups that I see is that data comes in, it gets used for the study it was originally used for, and then it's archived off into a dark, dusty corner somewhere. And we don't really go back and look at it. We don't go back and leverage it because it's too. That's not fair data, but that's really what happens. So how do we get to a place where we are routinely generating fair data?
So I've seen a lot of people basically say, as of today, everything we're going to do is fair. And basically everything behind it, everything that led up to that point is left in those archives somewhere in somebody's basement, right? Right next to the boiler room and the guy with the red stapler.
Mhm.
I think what it does is that hides, or I should say, unfairly disposes of data that led that company up to that point, right?
So we'll call that one declare bankruptcy. Start fresh.
Right. Yeah, no, absolutely. And I've seen this model multiple times. At a certain point, you're right. It is too hard to implement FAIR on legacy data, so we're just going to start fresh, right? Now, within the context of AI, I think it is much easier to train and use structured data that would be in a FAIR model, right? Understand that the concepts behind FAIR data predate the idea of AI ready data.
Absolutely.
So I think these targets have been around for quite a while. There is an advantage, I think, a speed advantage in being able to develop AI tools, right, or AI summaries from fair data structures, right? So what do you do about the legacy stuff, though? And I think that's probably more the point that you're trying to get at. It's like it is very, very, very hard to bring this kind of information in. And I think
but it's also a starting place, and to your point, that data was of value to get you where you are now.
so the question is how. I've seen multi-pronged approaches to this. One group will need this piece of data, another group will need this piece of data, and they'll be looking at the exact same set of inputs, right? But they'll be taking information or different information out of it, both of them, right? There tends to rarely be a holistic project that basically says, we're going to take all of our existing data and bring it into our structured systems so that we can actually use this as queryable information. I have seen proposals to be able to do this using AI systems, right? And basically crawlers that will then ingest everything you've got, right? And eventually convert that into an output that can then be brought into your systems. I've also seen ones where you have an AI that will take your structured data and then will also crawl your unstructured legacy data, right? And try to make a holistic summarizations and outputs. I don't know which is best.
I'm not sure any of us do. This is emerging and changing so quickly that the right answer has not materialized yet. I think. Go ahead.
Well, and it's somewhat dependent on what you're trying to do, right? I mean, I think one problem might be, gosh, we have all this data that helped get us here, and we can't use it anymore. So how can we quickly turn that into something that's leverageable, be it, in a fair, representation or otherwise, or, is cut and run a correct decision based on, where you might be. But I think one thing's for sure, the more data that you have, the better off you are to propel, these projects forward. And so, as James, you kind of alluded, we've done some experimentation lately of can we, take maybe some unstructured, unlabeled data that, might take a long time to hand label or otherwise parse through, pull in, a machine learning model, train it on maybe a subset of that, use that to sort of like, accelerate how you can ingest like the larger set, and in a sense these mini projects that help you build up to something that is more formally and well represented.
Yeah. And that gets back to the initial questions we had about mandate, as well as infrastructure, right?
Mhm.
If you have a mandate that says we want to bring in our legacy data, right? We want it to say, for example, match the approaches that we're using with our current structured data systems. If you have a mandate for that, do you have funding for it? Do you have infrastructure? Do you have the developers available? Do you have a partner who can help you with it? So, I mean, there's a lot of questions about that. And I think that almost has to be handled separately from the point at which you switched over to a structured system. And do you want that to actually look like your brand new shiny structured system, right?
It may never, because it may not have been collected in the same way, and
That's very
frequently
true.
was not.
Yeah, that's very true. So
I guess let's ask, sort of in your direct experience, the stuff that you're working on at Arrowhead, what are the good bits of tooling that have been successful? What are sort of the anti-patterns? What are the things that are clearly not helping or moving you forward or generating any return on your time or dollar investment?
I'll say that we're a little too early in the process to really talk a lot about
That's
what
fair.
those experiences are, because we're still at the do we fully understand how we wish to deploy a FAIR-based system, and how do we connect all this other data, right? So we're looking at different modalities now to try and figure out, do we want this information to be centralized? Say we collect the data from our existing structured data system and then merge it with information that we're pulling out of our unstructured and legacy systems, and then put that into a higher level structured system, e.g. Snowflake, for example, and then be able to use that as a centralized querying system? Or do we want to translate it in another way? Do we want to bring the legacy data directly into our existing systems, or do we just want to leave it hanging out here and query it ad hoc through the use of AI? So I'd say these modalities are things that we're currently testing and trialing. So outcomes on that are
Pending.
soon to be discussed. So, as you say, it's evolving. All right. So I think it gets to the core of what we're trying to talk about too. Is a very difficult problem.
And I guess maybe the follow on from that, you mentioned sort of who is this findable or accessible for? Who is supposed to be using this data? So is it the frontline scientists? Is it the line manager responsible for sort of a department or product? Is it more executive oversight, understanding what data is there? Like, who are you finding that access pattern to be for?
Yeah. What tools are you using to enable that? Right.
Yes.
So I can tell you that the dashboards that I make for being able to find and visualize aggregated data are very different depending on who and at what level are asking the questions. Executives want to see high level results, right? They want summaries on what SOPs were used. They want to know, for example, how many mice were used in a particular trial. But then you step down a level at your managers for each process, and they want to see how many workflows have been executed, how many were canceled, what was the output usage, right? So how many animals were actually used out of the ones that were brought into the trial, et cetera, things like that. And then you get down to the bench scientist and the lab assistants, and they want to know where their reagents are coming from. They want to know where the input treatment tubes are, right? They want to look at inventory management, things like that. So it's very granular depending on who is actually accessing the data and at what level. So they're very different, right? And I'll say that just in time sort of things are also highly dependent upon who's accessing it, right? Laboratory personnel, they want to see stuff as it's happening, because if I say put a tube of reagent in a freezer, right, they want to know that that's there when I do it. Does the executive want to see that just in time? No, they can wait 24 hours or a week, because the report outs are slower. So then that means the data goes into different kind of reporting databases for those outputs, right? And again, different tools, right? Do you use Power BI? Do you use Databricks, Snowflake? What are you using to report?
I think the concept of all of those different roles and how we surface this data to fulfill those, because we talk about, if we go back to the beginning, talk about the mandates that might come down. How can we, at an organizational level, use these tools to be more efficient, more effective? That's not a one-way street, right? That's a dialogue, a back and forth between all of these different stakeholders within an organization to help facilitate that. I think, and I can say from the collaborations that we've had at Yahara and the projects we're working on, the availability, the ability to pull out data from a broad set of underlying, disparate data sources, through things like, agents and LLMs and contextual search through those. I mean, it's really astounding what you're able to do, coupled with maybe some more formal approaches like George, like the Snowflake or the other like more maybe curated queries or things at that nature. But we're really at a stage now where if you know where to look, the tech is available to start pulling that in and help shorten that cycle. And I think maybe that's one of the most critical things that organizations can realize and start implementing is just the ability to ask. Can I get
Yeah.
the answer to, do I have the data that I need?
Yeah, and I think that's where there's a lot of contextual use of AI is well positioned for that because and I think about and by that I mean things that are literally querying your system and your system only.
Mhm.
Because the added bonus of an AI and being able to actually talk to your data using natural language is very useful, but it becomes I'd call it an AI assisted query, right? Kind of thing.
Mhm.
The one thing I have noticed with some of these though is that hallucination is a very real thing, and if said information doesn't exist, so you ask the system, do we have this piece of information? Do we have this assay result for this particular study or this particular treatment? And it'll come back and say, sure, and here's the results. It completely fabricated. So we do see that sometimes with these systems because the systems are, even though they're being treated like a search engine, they're designed to give an answer, right?
Mhm.
They're not specifically told to, once you've gone down so many leaves and you don't have an answer, just tell me you don't have an answer.
And I think that speaks to the ease of getting started with some of these kinds of tooling versus the complexity of getting them right. I will tell you, I have seen some success with more finely tuned AI types of queries where you can make it clear as a guiding principle in how you set up the system prompts that drive the.
Mhm.
There's a user query and then there's a system level configuration that sits over the top of that. It is possible in that system level to put some safeguards around it and make it clear that the right answer is data that is backed by evidence, and I should be able to click through and see the evidence in the data, and that it is better to return an empty set, a NA, right? Give me back an indication that it's not there in the data and that that's the right answer if it's not there. You can get the system to do that. But again, we're in that set of access patterns and new optimizations that we weren't necessarily doing before. That's not something you would have had to think to do for your query engine in the past because it wasn't trying to return to you that answer. So there's a very different set of optimizations to get AI right in that context.
And I think that's habitually a problem with LLMs in particular,
Yes.
and chatbot approaches to things, is that you have to build out prompting that allows for guardrails. I think when you get down to, like SLMs, right, or agents, I think those tend to have much more specific training sets in
Mhm.
particular. So very, very narrow focus on that. And then agents are by definition given parameters in which to return or not return information, just like you would typically build, a loop in your program kind of thing. If you hit the end and you don't have something, bail, right?
Adam, I think that's your opportunity to step in here and provide a little bit of guidance about how do we start to leverage some of these tools with a better engineering perspective on it. Give us some wisdom.
Well, right, and I think what's interesting there to that point, George, is, this may be an argument for like that fact that, if you have a well-defined sort of fair system where you have regularized how this data is collected, how it's stored, being able to go back and do that validation, right? Being able to go back and say, okay, let me check what I've been told to ensure that it's correct. If you can lower the effort and expense to do that, right? Obviously, everybody feels safer, and I think that's part of all of these processes is the iterative. You can't set an AI loose without having some human in the middle, some guards around it, some checks to ensure that you're headed in the right path. We've certainly We've been dealing with that lately, and it's not about technology here necessarily. There are specific patterns. There's good engineering practices that can be applied as you're collecting and curating data and implementing systems. But it always comes back to, I think, process and validation. Can you go back and ensure correctness in the results and giving yourself a path for that?
Yeah, I think using fair data as an input and fair data systems really helps with that because particularly with structured data systems in particular, because there's an expectation. But the AI also needs to be engineered in such a way that it responds or returns references. So give me the link back to the original source data
Right.
for every conversation. So I think that's a critical component of any kind of data summary tool. And then James, as we sort of go back to talk about, what about the legacy data? You didn't build the legacy data to support AI. What is your risk aversion there? What's the level of this data is close enough? The AI may have fudged a few things. I mean, is it 0%? Does it have to be 100% accurate? Are you willing to accept some slop in the output that comes out or something that you can't verify?
And here I think you've actually got some hybrid approaches where you start with the AI tooling, you do some test data sets with it, and then you can get it to crystallize into code ways to shuttle the data over. And that's what you actually put into the production system. But you can do that after you've already iterated with the AI to see if you can get the structure back out that you want. And now you can avoid some of the, am I willing to tolerate any slop in my data? You can avoid that by never putting that necessarily into your database and still get most of the advantage of doing this through these faster, newer techniques that will get you to how do I move my data around a lot quicker.
Yeah, that good software engineering practices, right? Iterative software engineering practices go a long way towards that. Sometimes the mandates dictate a more rapid approach to things. We want to see something in 3 weeks versus sure, take your time to get it, exactly right.
Just right.
Yeah.
Yes.
So
Then maybe you tolerate some slop. You do. For those that don't know, slop here is slang for the AI making stuff up, and it will do it to you occasionally. I
big
think
time.
everyone who's used it to any extent, really leaned on an LLM will at some point have gotten back something that looks real and is totally fabricated. So,
And I would also bring up another, aspect there, James, of was the data originally correct? And
ooh,
what I look
ooh.
at, so recently
Okay.
we were doing some experimentation and went through the building of some models, and at the end of the day, I went back and I said, was the labeling right for this? And that's a human component, right? That's not was the data here? Did the LLM do a thing? Was the AI, it was the model, did it pick the wrong thing?
Did the humans
It
do
comes
the
back
wrong
to
thing?
people.
Absolutely, and I think any sort of data entry comes down to people. I think ontology is a huge problem that
Ooh,
we've seen as well. It's like, do two groups of people call the same thing by different names, right?
almost
Uh,
always.
yeah. So we've definitely seen some inconsistency across operations and discovery where ontology conflicts occur. So we've even seen things where systems are intolerant of spaces in the name or lowercase versus uppercase, even though they're calling them the same thing. So
It all comes down to the age-old problems we've been struggling with for years and years in software, in a sense.
I don't think that the problems that we've seen are, I mean, certainly there are unique issues, but it's kind of been interesting to look back upon my career, which spanned something like 35 years, and see the same problems that we've wrestled with 30 years ago surfacing again and again and again. And I think to get back to what you said, Adam, I think it's all about humans, right?
It all comes back to us.
It
Well,
does.
as we're wrapping up here, and certainly if anyone has any questions or comments in the chat, please drop a note or a Q&A question. But George, in this space of development over the next 6 months, what strikes you as an area of tooling that's exciting that you think is really going to start changing the landscape?
Again, I think AIs that are built into your systems so that they can actually return data summaries quickly, hopefully accurately. I'm seeing the development of these as a major boost to the research outputs. And again, it's sort of this coupling of the ability to query your data in a sort of a natural language way and get meaningful reports out that can help make decisions, right?
They're helping direct the science in a way that might not have been done before.
Very much so.
Faster.
And it is simplifying some of that generation too, because now you don't have to spend hours on end writing dashboard applications or things like that, or going in and finding individual things for patent applications or stuff like this. You literally just feed the AI and it kicks back a report formatted in the way that you want to see it. So it is really speeding up. And I think part of that too is taking that development out of the hands of dedicated developers and putting that power into the hands of the bench scientists and the people who are ultimately using the data. So I think it really speeds up that typical kind of iterative cycle.
Opening up access to the data in ways that weren't possible before, or prohibitively expensive in time or resources.
Yeah, I'm a huge proponent of enabling, and I think that's where most of the data structures need to go, is to basically increase the enablement of the bench scientists, the end users of the data.
So if you have the backing, the strategic initiative, the desire, a well-structured, thought through data set where you're able to consistently bring all of this together, and you start leveraging tools to make that available to everyone in ways that are applicable to their roles. I mean, that sounds like a big ask, right? But I think what we're seeing is the reality there is that effort is really coming down. If you do this right, if you think through it, if you put that on the roadmap and start following it organizationally as a strategy, that's how this all comes together. It's not necessarily a single project, a single initiative, but the bringing together of all of these opportunities to facilitate more than perhaps the sum of their parts.
Yeah, it has huge value. It has huge value to the business. It has huge value to potential customers and clients, and I mean, in our space, can more rapidly send drugs to trial so that we can get them into the hands of people who need them.
James,
Back to impact.
where do you see the tools, the technology going in this next 6 months that can really make a difference?
I think the biggest thing that George argued for sort of the AI inline baked into the system. But in a lot of ways, you're still distributed across a bunch of systems and a bunch of databases. I think the biggest thing that makes a change in this space is clear right ways to start to get some of these technologies integrated into your laboratory that maybe sits a little outside the system and can access multiple. And this is very different than pulling up a ChatGPT window in your browser. This is starting to get it much more natively into the environment and start to build best practice workflows around this stuff. The tooling to do that is not really there right at the moment in a holistic way, unless your enterprise has already invested significantly in how are we going to do this? Yes, there are some ideas out there. Yes, there are some baseline pieces of tooling, but most enterprises that I've seen have not. How do we start to get that available to be used? Because as soon as you can get it in, you can start that iteration. And George, you started to allude to it, the breaking down the little bit of the wall. If you had a programmer with some expertise and they could get to the data, they could do a lot of work to build up these dashboards or summarization tools or whatever. But that person is somewhat unlikely to be your subject matter expert on what the data is being used for, the science, the impact that it's going to deliver, actually, impacting your business, the patients that are maybe going to be receiving treatment off of this. You're not getting crossover between those two things. If I can start to break that wall down and get your subject matter expert directly on top of the data, and they're the ones that understand how to get the impact and the value back out of it, that's the value in why are we talking about these more agentic style systems, starting to use these tooling. It's breaking down that wall. That's where I see the next 6 months to a year starting to go.
Yeah, I think that is very true, and I like that. I like that breaking down the wall analogy. I think it works well. Certainly, our scientists have appreciated having a tool where they can talk to the data instead of having to come to me or any of our other developers. So yeah, absolutely.
Yep. Tear down the wall.
There you go.
Good flexible tools, good process.
Yep.
Bring the data to the people that need it,
Yes.
and work with your partners to make it happen. We're coming up on the hour. George, thank you so much for joining us today. I always love having a conversation with you. James, as always, it's been fun. We'll be doing this again next month. We do hope you'll join us. James and I will be talking at the AI and Lab Software Digital Summit hosted by Lab Manager. And we'll be talking about lab data and artificial intelligence insights, and actually a little bit of a walkthrough. We alluded to maybe some of the experimentation we've been doing today, but we'll talk about some practical experiments that we've been done, and how easy it is and how accessible it can be to build your own machine learning models and get those applied to data that might start out a little bit messy, and how you can actually turn that into something actionable and useful. So please do join us, and as always, feel free to reach back out to James or I with questions you might have. We'd love to start a conversation.